Hey everyone, Mr. Hauk here. In today's video, we're going to be using right triangle trigonometry to solve application problems. Let's go ahead and get started. So recall from a previous video what SOHCAHTOA is. SOHCAHTOA is an acronym that when given a right triangle, we can use SOHCAHTOA to calculate an acute angle theta as the ratio of sides relative to that angle. So let's say that angle A is theta. Well, then the sine of theta would be the opposite leg to theta, which would be leg BC, divided by the hypotenuse, which would be AB, since AB is directly across from the 90-degree angle. So sine of theta would be the opposite leg divided by the hypotenuse, cosine of theta would be the adjacent leg divided by the hypotenuse, and the tangent of theta would be the opposite leg divided by the adjacent leg. Keep in mind that SOHCAHTOA is relative to the angle. So if I was more concerned with angle B, then instead the sine of theta would be AC divided by AB. So you need to be careful with which angle we are looking at. So when we talk about application problems involving right triangle trigonometry and SOHCAHTOA, there's two definitions we need to understand. The first definition is angle of elevation. An angle of elevation is the angle between the horizontal line of sight and the line of sight up to an object. So let's say that this person right here is looking up to this person right here. Then this angle would be the angle of elevation. An angle of depression is the angle between the horizontal line of sight and the line of sight down to an object. So let's say that this person is looking down to this person. Then this angle would be the angle of depression. And also note that in this case, the angle of depression and the angle of elevation are equal to each other due to alternate interior angles, since these two lines would end up being parallel to each other. But let's go ahead and try some problems. In our first example, a building is 50 feet tall. At a distance away from the building, an observer notices the angle of elevation to the top of the building is 41 degrees. We want to know how far is the observer from the base of the building. So the angle that we are concerned with is 41 degrees. We know that the height of the building is 50 feet, and we want to know from the base of the building how far this person is away. So we're looking for the length of this leg. So I'm going to go ahead and label that X. So since we have relative to the 41 degrees, we have the opposite leg and the adjacent leg. That tells me that we should use the tangent. So we're going to take the tangent of 41 degrees is equal to the opposite leg, which is 50, divided by the adjacent leg to 41 degrees, which is X. Multiplying X on both sides, this will give me that X times the tangent of 41 degrees is equal to 50. And dividing both sides by the tangent of 41 degrees, we get that X is equal to 50 divided by the tangent of 41 degrees. Let's go ahead and approximate this. So notice that I already have Desmos pulled up. Let's double check that we are set to degrees. So if you are set to radians, make sure that you are set to degrees since our angle is in degree measure. And let's go ahead and calculate 50 divided by the tangent of 41 degrees. And this gives us approximately 57.5. So this is about 57.5 feet. Notice that I'm being careful to use my units because this is an application problem. In our second example, a plane is cruising at an altitude of 30,000 feet and wants to land at Hartsfield-Jackson Airport in Atlanta. The plane must begin its descent so that the angle of depression to the airport is 7 degrees. How many miles from the airport must the plane begin to ascend? Well, one thing that I noticed real quickly, and it's important to notice this, and it's actually really easy to miss, is that we have different units here. Notice that we're given that the plane is cruising at an altitude of 30,000 feet. However, we want to provide the answer in terms of miles. So we want to keep that in mind for when we start to approach the end of this problem. So let's go ahead and take note of what we have here. Our angle of depression is 7 degrees, and we know opposite to the angle of depression is the 30,000 feet. What we are trying to find is the distance that the plane must begin to descend. So I'm going to go ahead and label this as x. So the distance from the plane to the airport, because the airport is right here, would be x. So we have the hypotenuse. Notice x is the hypotenuse because it is across from the 90-degree angle. So we have the hypotenuse and we have the opposite side. This tells me that we want to use the sine. So the sine of 7 degrees would be equal to 30,000 divided by x. While multiplying both sides by x, this will give us the x times the sine of 7 degrees is equal to 30,000. Continuing to work down here, dividing both sides by the sine of 7 degrees, this tells me that x is equal to 30,000 divided by the sine of 7 degrees. So let's go ahead and use Desmos to approximate this. Again, we're already set in degrees for Desmos, which is important. So let's go ahead and calculate 30,000 divided by the sine of 7 degrees. And this gives me approximately 246,165 feet. But recall from the beginning of the problem that we pointed out, we want miles. So we want miles, which means we are going to need to do a conversion. Well, we know that 1 mile is equal, that's a terrible I. We know that 1 mile is equal to 5,280 feet. So since we have our answer in feet, let's go ahead and divide 246,165 by 5,280. So again, I'm going to use Desmos to do this. So 246,165 divided by 5,280 will tell us that in miles, the airplane needs to be approximately 46.6 miles away from the airport before the airplane starts the descent. So approximately 46.6 miles. All right, and looking at our last problem in the notes, a ladder leaning against a vertical wall makes an angle with the ground. If the foot of the ladder is 3 meters from the base of the wall and the length of the ladder itself is 7 meters, what is the measure of the angle the ladder makes with the ground? And we're given a hint to go ahead and draw a picture. So let's do that. Let's start with our vertical wall, and we have a ladder leaning against the vertical wall. And we know that the ladder makes some angle with the ground. So let's call this angle theta. And we know that the length of the ladder is 7 meters. And we know that from the base of the wall, the ladder is 3 meters away. Okay? Essentially, we want to find this angle that the ladder makes with the ground. So relative to the angle theta, we have the adjacent leg and we have the hypotenuse. And we know we have the hypotenuse because this is our 90-degree angle right here. And 7 is across from the 90-degree angle. So this tells me that we want to take the cosine of theta. So the cosine of theta is equal to the adjacent leg, which is 3, divided by the hypotenuse, which is 7. Now remember from our previous lesson that in order to find an angle, we need to take the inverse of that trig function. So we're going to take the inverse cosine of both sides. On the left side of the equation, we simply have theta, and on the right side of the equation, we have the inverse cosine of 3 over 7. Let's use Desmos to calculate this. So we'll do the inverse cosine of 3 divided by 7, which will give us approximately 64.6 degrees.